Hey guys, Alan here. Welcome back to my workshop. This is a bit back to front here. I'm doing this intro after I finish the project, mostly because I wasn't sure how it's going to work out. But anyway, I'll dive straight into it. The idea here is to get some practice using the rotary table to cut curves and make a piece that might be useful for my horizontal bandsaw. So let's get straight to it. So I have this horizontal bandsaw, and I imagine many of the people watching this channel will also have something very similar. There must be thousands of these things in the world, if not millions, and it's a pretty reasonable machine. It generally does what you want it to do, but there are several aspects of it I don't like, which I want to make an improvement on. The first cab off the rank today is looking at the way the back jaw of the vise here, which can swivel using a clamping bolt in that quadrant slot. The way that you have to tighten and loosen this bolt is really annoying. I'll stick the camera up underneath, and hopefully you'll be able to see. Hopefully you can see that there's just a nut on the back there. So to make the adjustment here and tighten and loosen that bolt, you need a spanner on the top and a spanner on the bottom. It's not hard, it's just awkward and irritating. So I want to replace the nut and washer arrangement that's under there with a T-nut, but because this is a quadrant, then the T-nut needs to be curved as well, so that should be interesting, making a curved T-nut. So that's what I'm going to get on to now. Okay, well we need to start with some dimensions. Let's have a look at the radius of this quadrant, and it looks to me like it's about 108, maybe 109, so we'll call it 109. And the width of this slot is about 14. The slot's rough cast in the aluminium, so a rattling good fit's what we're looking for. So I might even go for, well, certainly no more than 14. And of course the other dimension that's important is the height of the rebated part of the nut, and it looks like that can be almost 10, but I guess 8 will be fine, so that's what we'll go with. And of course I've got to check out what that is. I think that's probably an 8mm bolt. Okay, so even though this is a project making a piece for the bandsaw, it's still going to start with hacking a piece off with a bandsaw. Right, on to the next bit. So I cut this off a piece of bar stock, which I'd cleaned up previously for making some other T-nuts. So all I have to do here is just clean. Now I've cut a piece off to length, just clean the ends up and we're good to go. Flip it over and clean the other end up. Okay, so let's finish that alright. So it's time to switch over to a setup on the rotary table so I can cut the curved faces on the male part of the T-nut where it goes up into that quadrant slot. Okay, so I've got a milling vise on the rotary table, and what I have to do now is locate an origin or a centre of rotation so that when I turn things I get the right radius of curves on the T-nut. So to set my origin, I've machined a disc up here with a 10mm hole in it, and the disc is the same diameter as the width of the piece I want to work on. So this can set my centre of rotation, and if you look up into the collet chuck, I think you'll be able to see that there's a dowel in here, a 10mm diameter dowel, which will locate in that hole. So when I bring this down, that'll go in there, and so it now gives me that absolute origin position as a centre of rotation, again from which I can measure the radius, the radiuses that I want to use for cutting the shape of this curved T-nut. I'll go over to the whiteboard and maybe it'll make a bit more sense. Okay, so let me have a go at explaining what I'm trying to do here. So I want to make a curved nut, so there's going to be a rebate, 2 curved rebates and a centrepiece, and I'm going to be milling it out of a square-sided piece. So one of the things I wanted to know is how much it was going to come in on the ends. Well, my good friend Pythagoras is batting on my team for this one, and it's actually quite easy to work that out. I won't go through it, you can probably see for yourself. Anyway, it suggests that I'll come down about 1.5. So that's all right. The piece of material is going to be big enough. So then the next bit is I need a centre of rotation to mill these curves, and as you saw me measure, the distance between the pivot bolt and the lock bolt on the bandsaw was 109. So that puts a point in the middle of this curved T-nut. And I want this middle section, the male bit, which will fit in the slot, to be 14 wide, so I can work out from that the radius is that I need to work with. So I won't actually be cutting it round on the outside. I'll be just doing the shoulders. So the dimensions I really care about are setting the cutter at 97, because I'll be using a 10mm cutter, so it'll actually cut 5 over. That'll give me the 102 line that I want. And going the other way around, I'll cut it to a 121 radius, which will then cut it, because it's a 10mm cutter, we'll do 116. So between those two, that's where my 14 is going to come from. So hopefully that makes sense. But what's critical to all of this is finding this point. And that's what I've done with making that bush and using the dowel and the quill. So now I know where that is, and I can measure away from that to set these radiuses. So that's what I'm going to do now. Hopefully that made sense. Maybe it'll be easier when you actually see me do it. So what I've got here is a bush with a 10mm hole in it, and it's engaged on a V in the middle of this jaw here. So that hole there is in the middle, this way, of the vise. And perhaps you can see there's a 10mm dowel hanging down there. So if I come in here, you can see that lines up there nicely. And that tells me that the centre line of this vise is over the centre line of the rotary table. So that's the first piece of the setup. And I've also run a dial gauge along the side of the device and aligned it with the y-axis. And then this ground parallel here is clamped up against it, and I repeated the check running a dial gauge against the side of this ground parallel. So now I know that the device is centred on the centre of rotation of the rotary table, and against that parallel it can run in parallel with the y-axis. So that's the first part of my setup. So now I want to replace the bush with the workpiece and get that centred in the vice jaws, and then with that done I'll be able to mark a cross on there to show the centre point on that top face, and then I can use that to position the centre of this piece 109mm away from the centre of rotation of the rotary table. Okay, so I've got the workpiece in the vise now, and I use the calipers to scribe to cross the lines and hit it with a small centre punch. So I've now got a little tiny divot in the centre of this piece. I don't know whether you can see that. Let's get in a bit closer, maybe you better see it. So now if I drop this guy down there into that divot, yeah, that feels pretty good. So workpiece is now centred on the centre of rotation of the rotary table and on the quill, so at least I know where it is now. So next thing is to move this centre point 109 out that way and clamp it, so I've got room for a cutter to do the arcs I need either side, which will be either side of that. Right, so what we're going to do is bring the table this way 109, and then loosen this off and slide the vise 109 that way and recentre it under that. So that'll do for that. So slacken this off and move that way. take that out. Forward's 109. Okay, we're all set now. We're sitting on the centre line, 109 out, which is where we want to be. This little guy is still in the dimple. Might be a bit hard to see, but anyway, he's still marking the thing. And you'll also notice we've got some substantial clamps to hold this thing in place. So we're all set to go now to start milling the curves for the sides of this curved T-nut. Okay, so I've adjusted the cutting radius to 121, which should leave me a 5mm wide land round here, and I had a quick check with the rule. It looks like it's about right. So I'm going to take a 0.1mm depth of cut around, just so I can have a proper squiz to make sure things are going the way I want them to go. Here we go, fingers crossed. Have a bit of an inspect and run the rule over that. So that is indeed 5 at the back, that's good. So I think we'll come around and do a cut in the front now and make sure that's alright as well. Just come in there. I've got to do this cut from the other side. So we'll come in to our calculated 97. Lock that off. So now when I cut back that way, I should finish up with a centre piece here, 14 wide. Well, let's see what do we get. The calipers and have a check. It's a bit hard to measure such a shallow thing accurately. And it's looking somewhere near the mark. It's certainly not under 14, so I'll do a couple more cuts at greater depth, and if I have to fine tune it, well then that's what I'll do. So back to 121. Oops. And I'll go somewhat deeper this time. We'll take it down to, I think we should be able to go millimetre depth of cut without any trouble. Now, I better set up some cooling. Unfortunately, running this mist cooling means my compressor is going to run pretty much non-stop, so won't be hearing anything worthwhile for a little while. see what the width really is. Well, we're shooting for 14 and we got 1409, that's good enough for me. So I won't bore you with a whole lot of repetitious stuff. I'll bring you back when I've made a lot of progress with cutting these curves. Okay, so I'm down to 7mm both sides, and I'm wanting 8mm, so I've got another millimetre off each side. Now I'm getting down pretty close to the top of the vise here, which I don't know how well you'll be able to see that, but when I come down to 8 I want to make sure that I've still got clearance. So we'll come down to 8 while it's not running. Right, and that's set at 8. Yeah, I'm happy that there's a bit of clearance there. Right, here we go for the last 2 cuts. Okay, that's got us down to 8 on both sides. 2 curves complete. It's made a bit of progress. So next thing is going to be to mark out and drill and tap 2 8mm holes for the clamping screw. Okay, so I've got my radius set to 109, which is the centre line of this beast. I've marked out the location of my holes, so let's get drilling and then some tapping. Okay, I said earlier that I wasn't going to bother with radiusing the back side of this T-nut. So I changed my mind to look a bit better. I guess if I do, I think it's not going to be that hard to do. So the back side is about 10 thick, a bit over 10 thick. So I only need a flange on the back side of the nut. Well, probably 5 thick would be good enough. So it still leaves 5 or thereabouts in the vise to hang on to. So I need to be able to take this out and put it back higher up in the same place. So I'm able to use the backstop, which I've got, or the vice stop I've got in the adjacent milling vise, to give me a location point for that. So now I can take this out, put wider parallels in, and lift it up. So that's what I'll do. Okay, so I've reset the nut in the vise on wider parallels, and I've now got 7, you can't see it very well, but I've got 7mm sticking out clear of the top of the vice jaw, so I'll be able to come down 6mm, and then I'll machine the back of the nut off afterwards. So I'll finish up with the 8mm of the male bit to go up in the slot, backed up by a 6mm flange across the back of the slot. So that's the plan there. And as to how deep I go in, I go back to my calculation with Pythagoras that I showed on the whiteboard, and there's actually an error there. For some reason I showed the radius as 121.1. It should have been 120. Anyway, when I recalculated it, the in-depth, the difference between the depth at the edge and the middle is 1. So I'm going to use that as the number for how deep to go in with this curve for the flange. So that's that. Now this vice stop can now be swung out the way. That's one of the reasons why that's such a useful design. And I'll come down. So I'm set at a radius of 93, which will give me the 1mm in the middle. We'll set that to 0 on the quill DRO, which you can't see, and come back out the way here. So I'll be coming a 1mm deep cut because this isn't held in by a lot. It's gripping on about 4mm, I think 3 or 4, but I think it'll be right if I take light cuts. So I think we're good to go. So like before, because I'll be using the mist cooler, it's going to get really noisy. Now, sorry about that. Well, that's it. That side's down to 6mm. Now the back side is supposed to be cut on a radius of 126, so we'll do a very shallow cut just to test how that looks and take it from there. Well, that turned out okay, I think. Okay, so I've finished doing the curved flanks. I'm going to turn my attention to the ends now. And on this end, I just want it milled off flat on a line which is a radius from that curve to the centre point. Now this end is different because I only want to take this the bit that goes in the slot down to the shoulder, because there's room at this end of the slot for this to go under, which wasn't the case at that end. You'll see when we do a fit. Anyway, so I'll take this one down to that level. I don't know how well you can see that, but that's turned out pretty good. Alright, so I think it's time to pull it out of this setup now, because I've got to turn it over and mill the back off, and then work out how to radius this end particularly, but probably both ends a little bit. So let's pull it out, clean it up and have a proper look. Well, that's definitely one of the more complicated shapes I've tried to make, probably the most complicated actually. It's coming along nicely. So you probably realised what I was talking about before, so I'll be milling this flat piece off, but it's still useful to hold it while I'm working with it. Right, so I've got to mount it now so I can radius the corners, particularly on this end, but I might as well do both ends. Okay, so I want to round the ends of this thing off now, and I want the centre of rotation to be in the middle of that threaded hole. So a bit of a head scratch, but what I've done is set the rotary table so that its centre of rotation is under the centre of the quill. The vise is back where I had it before, so that the centre line of the vise passes over the centre line of the rotary table, and against that parallel it's free to move along the y-axis. I put a tap in here, a threading tap, this guy, and with that in there and this loose in the vise, I could put the top end of the tap into the chuck here and float this to a position such that the centre of this threaded hole is over the centre of rotation of the table, and also in the centre of rotation of the quill. So then all I have to do is move the table with the offset that I want to create the radius for the turning. So I've put this pointer in there so you can see what's happening there. I might just reset the radius to 7, being 4. This is an 8mm hole, so the 7 is half of that, that's 4, and then 3 on the end. And if I rotate this now, hopefully you'll be able to see that it's going to come out to about the right place over there. And the right place over there. Alright, so I've repositioned the rotary table to its index position so that the vise will move parallel to the y-axis, and I'm offset to 12 from the centre line of the hole here to allow for the 7 I want and half the diameter of the cutter. So let's get cracking and see what happens. Alright, we'll go around once more at 8. I'll give you a closer look at that later. So now I've got to repeat the exercise, a similar sort of exercise to do the back corner. Okay, so that's got those ends radiused. All that's left to do now is cut this backing piece off. They'll clean up just fine with a bit of a file on the edge. Okay, so here's the finished item. It's definitely the weirdest shaped thing I've made. It was a good introduction to machining using the rotary table, because it's the first time I've tried to do that. So guess we better go and see if it fits. Okay, so let's see how well it works. Well, that seems alright. Let's make sure we can still get the blade at 90 degrees. So I don't know how well you can see that, but that's pretty much perfect, so very happy with that. And of course it achieved the original goal, having to crawl around underneath with the spanner. Now there we go. Okay, well let's finish that. The end result's perhaps not very inspiring. It's a little tiny piece. But keep in mind, my primary goal with that project really was to have a reason to come to grips with the rotary table and cutting radiuses. It's not something I've done before. I just haven't used the rotary table that way. So it's quite a learning curve for me. And I changed horses a couple of times in midstream, as you possibly noticed when you're seeing what was going on there. Now, I didn't help myself by making a couple of mistakes. But it all came out in the wash. And the piece, as you saw, does what it's supposed to do. And I'm much more confident now about tackling such things with the rotary table. So I hope you enjoyed it and maybe learnt something from it, and maybe some examples of what not to do. Maybe you sat there screaming, no, not like that. Anyway, thanks for watching, and I'll see you in the next one.